Squaring a number is when you multiply that number by itself. This is already interesting by itself. For example, any real number squared results in a number that's guaranteed to be non-negative. We know that 0 squared is 0, very interesting, and every other number squared is positive. This makes squaring a useful tool for guaranteeing that your number is positive, and allows for some pretty straightforward tricks like the Pythagorean theorem. But we're not here for simple and straightforward tricks. No, we want to discover something interesting. Let's take an example like 10 squared. The result of 10 squared is 100. Okay, now let's split 10 squared into 10 times 10. Now let's take these two 10s and increase one of them by 1 while decreasing the other by 1. Here we see that 11 times 9 is 99. If we continue this pattern, we get 12 times 8 is 96, 13 times 7 is 91, 14 times 6 is 84, 15 times 5 is 75, 16 times 4 is 64, 17 times 3 is 51, 18 times 2 is 36, 19 times 1 is 19, and finally, 20 times 0 is 0. And even though this is an edited video where theoretically I could take as much time and as many takes as I need to say that whole thing super quickly, I don't need to, because I already know them. And it's not because I know my times tables. Oh no, it's certainly not because I know my times tables. It's because there's a pattern in this chart. Do you see it? Well, let's take the difference between 100 and each successive term in this sequence. We have 100 minus 99 is 1, 100 minus 96 is 4, 100 minus 91 is 9, 100 minus 84 is 16, 100 minus 75 is 25, 100 minus 64 is 36, 100 minus 51 is 49, 100 minus 36 is 64, 100 minus 19 is 81, and finally 100 minus 0 is 100. Therefore, we can see that any square number, when provided a fixed sum for which we take the product, the square number is decomposed by subtracting off successively increasing square numbers. The wildest part is that this pattern continues into the negative numbers, as you can see here. This can help you with tough multiplication that you need to do quickly in your head when faced with something like 42 times 38. Since 40 times 40 is equal to 1,600, we know that 42 times 38 must be 1,596 because 1,596 is 4 less than 1,600. To demonstrate how powerful this tool is, while I was writing the script for this segment, I didn't even believe that 42 times 38 is 1,596, and I had to type it into a calculator to make sure I haven't gone too far into math mania. And that's it for today. Have a good one, folks.